Thanks, Alex.
Too easy.
Well, afternoon, everybody. I don't know who had a chance to do this. I'll ask you in a sec. So, clicker problems. Helps when you plug it in. Cool. So the title of my talk is Forgetting Your Passwords with the Web Authentication API. There's my Twitter handle and hashtags and all that kind of thing, because that's what we do these days. Who has heard of the Web Authentication API? That's a lot more people than I thought. Who has used it? 2, all right. And have you used it in production? You have? Wow. Okay, maybe you should be doing this talk, because I haven't. Yeah, so who had a chance to look at that demo while you were waiting, filtering in? And that's, what, 5, 10? Did it work? No. Great. Do you have iPhones? Yes. Great. Okay, we'll talk about that. But we couldn't be here today without our sponsors. There are a whole bunch of them. They all give money. And without them, this conference wouldn't happen. Or if it didn't, it would cost you a lot more than $60. So thanks all to them. And the volunteers and the other speakers and committee members. Lots of people go into this day, and it's a big one. So what we're going to talk about today is, I guess we're going to set a little bit of a, make sure everyone's on the same page. We'll talk about what authentication is, why passwords are bad and why we should try and get rid of them, the Web Authentication API and how that helps us get rid of passwords, and then talk about what that means in terms of what we're going to build for our users. So first of all, authentication is about proving your identity. That can happen through 3 ways at the moment. We've got something you know, which is usually a password or a PIN number, something you have, like your phone, you'll get a text message, or something you are, which would be your fingerprint or your facial recognition kind of thing. And the way authentication works is we'll start off with a guy like Dave. And Dave wants to get into a club, so he meets a bouncer. When he gets to the front of the line, the bouncer says, "Hold on a second, mate." Dave goes, "Here's my ID." The bouncer has a look at that, looks at a few things on it and says, "All right, you're good to go. I've verified who you are." That's not quite authorization. That's the authentication part of it. So at this point, he knows that you are who it says on the card. But he doesn't know if you're allowed in. That's going to be decided on things like your age, whether you're drunk already, if you're on the list, or if you're wearing the right shoes. And the important part of this exchange is the ID. Now, the ID has a few things on it that help us know that it's something that proves who you are. It's issued by, for example, the Department of Transport. It's got holograms and that kind of thing. And it's got a picture of you. And by looking at that picture and knowing that you trust the document itself, you can trust that the person is who they say they are. That's kind of the same thing we have with passwords, where it's something that I know and I give to you, and you can validate that it's the right password, at least if you're a server. I'm not a server, but let's say we are. But passwords are really bad for people to actually use. You know, we're not good at creating passwords. The top 10 passwords that are most frequently used are all crap. And, I mean, 1, 2, 3, 4, 5, 6, you wouldn't have a hard time guessing that, I suppose. Password, because I guess it's the default, I don't know. The one that I'm not sure about on there is Dragon, number 10. But between those 10 passwords, that covers like 1.6% of accounts, which sounds like a small number, but if you think of Facebook with 3 or 4 billion accounts, 1.6% is many millions. So, you know, you don't need to try a lot of passwords to get into a lot of accounts. But you go, yeah, passwords on that list, and that's a really bad password. I know that, you know. I know that I need to have a capital letter, or I need to put a number on the end, or maybe I replace one of the numbers with a symbol, and now I've got a good password. It meets all the complexity rules. So those don't really help either, because you end up with passwords like this. And then you have things like forced password changes. You know, let's say you're in a corporate environment. A lot of the time you'll need to change your password every 3 months. So what do you do then? You change that number from a 1 to a 2, and every 3 months, you know you've been at the company, you can divide that number by 4 and find out how long you've been there. We're not very good at remembering passwords either. You know, we all know that we need to make different passwords for every account, but I reuse passwords all the time, and 60% of people admit to it also. And password resets, if you do forget, they're really slow, they're expensive. You know, I can't imagine having to call a help desk or sit on a help desk and ask for a password reset. all day, every day. So passwords are bad for everyone, really. They're involved in things like data breaches, where your password gets leaked anyway. We reuse that password, so if they get it on one site, they can use it everywhere. We all use common passwords, so even if you're not in a breach, there's a reasonable chance you can get in. And then you have things like phishing attacks where they can just get your password like that. And a lot of those problems come down to the password being a shared secret. It's something that both parties need to know, the person trying to log in, for example, and the server itself. So do you think you can trust other people with your secrets? I don't, but who in the room wants to share a secret? No. Okay. 81% of all hacking-related breaches come from stolen passwords, so that kind of reinforces that maybe you can't trust people with things that are secret. And then you get things like, have I been pwned? And I've ended up on here a few times. Who else wants to admit to it? Most of the room. So, you know, clearly we're not doing it all right. And the way we have traditionally dealt with passwords as developers, we'll go, yeah, I'm not sure I know how to do it, so I'll just implement social login. Let Facebook store the password. You know, they know what they're doing. But do they? Facebook, GitHub, Twitter, Microsoft, Google, they've all had data breaches where passwords have been exposed in plain text. Often that's when they're logging them in web servers and that kind of thing. So social login's kind of out then. But what about, you know, multi-factor authentication? I get an SMS every time I need to log into a new device. And that's okay. It's better than nothing, certainly, but it's not perfect either. This guy, Sean Kuntz, lost 100 grand in Bitcoin because someone stole his password. It's surprisingly easy to do that. I know, I work for Telstra. So multi-factor authentication isn't great either. What if we didn't need to store passwords at all? That's where we end up with the Web Authentication API. The Web Authentication API enables passwordless authentication or simplifies using multi-factor authentication. And it does this by delegating the responsibility for authenticating a user to their own device. You don't need to do that yourself, you just get an assertion that that person is who they say they are from a device. And what that means is that we never have to send a secret over the internet. So how do you use it? Well, you can use one of these, a YubiKey or similar. Who's got one? But I did this at Fenders the other day and more people had their hands up than I thought there as well. So that was, I don't know, 2 dozen or so. Whose mum has one? Okay. So there's a bit of a challenge there. What you call this is an external authenticator or a cross-platform or a roaming authenticator. How about a fingerprint, or I guess to be more specific, a device that lets you log in with your fingerprint, like a phone? A lot of people. Whose mum has one of those? A much better number. So to me, that's where the promise for this API actually comes from. These authenticators, you can use your Android phones or your iPhones, maybe, as authenticators in themselves. So they will actually prove that you are who you say you are by using your fingerprint. And those are called internal or platform or bound authenticators. So for those who didn't get to do the demo, I'll show you roughly what that looks like and what it means when you're logging, or what you have to do when you're logging in using the Web Authentication API. So you start off on this site, for example, WebAuthn.io, and I'll enter my email or username, and I don't need to enter a password. And I click register. I'll get a little prompt from my browser telling me to enter my security key, or if you do it on your phone, it'll ask for your fingerprint. You probably have a few prompts before that to say what kind of key you want to use. And then you touch it and you're good to go. You can log in pretty much the same, you just touch a device. So it's really simple. You don't need to worry about doing a whole lot of validation of what that password is and making sure you're hashing it because there's no password to store. So have a look at what actually does get sent around. In this case, the 3 main parties are your authenticator. I've used that symbol, but that could just as easily be your phone. The browser and the website server. So to start off by sending a username and maybe a password, because I said you can use multi-factor authentication. And then the server will respond with a challenge. And the challenge is basically a sort of shared secret, but it's not a secret. So it's just something that both sides use at the end. It'll also send back some details about the website itself, like a display name to display in those prompts, and some details about what kind of authenticators it'll actually let you use. You know, are you going to let people use their phone, or maybe you only let people use those hardware ones? Basically, that gets passed on to the authenticator, and then the authenticator will do its thing, and you tap the button or whatever, and respond back with some more data, signature that needs to be verified by the server, credential ID, and a public key, which needs to be stored by the server. So those go to the browser. Obviously, you've got to get them to the server, so you do that bit too. Now, there are a few different parties here, and we have different specs that actually define what each bit is. So there's the Web Authentication API, which you'll see shortened as WebAuthn a lot, because typing out the Web Authentication API takes a bit longer. And that defines what happens between your browser and the website server, and I guess their JavaScript website as well. And then you have the client to authenticator protocol, which talks from the client to the authenticator. So that's from the browser or your operating system to the authenticator itself. And those together form FIDO2. So a lot of the time you'll look up and see FIDO2/WebAuthn if you Google or whatever. And I talked a bit about the magic that the Authenticator does, so we can have a little bit of a look at that now. The Authenticator has three main things that it does. Firstly, it verifies your identity. And it does that through possession and/or a PIN number or a biometric reading from that. And that kind of means you have two factors in one. You know, we talk about two-factor authentication being something you know and something you have, or something you are. We've kind of already got that. By being able to press a button, that proves that you have it, and by having a PIN, that proves that you know something, or by using a fingerprint, proves that you are something. So you kind of get two factors in one, which is why you can use this as a strong single factor. Then what the credential does is stores a credential, and that credential is scoped to the website that you've actually gone to. It stores the URL and maybe a user ID so you can log in with multiple accounts on one website. And what that means is that the credential won't be given to the wrong website. So if you have a phishing website, it won't get your credential information. And even if it did, it's public anyway. You know, you have a public key, you're not sending a private key over the server. So I'm going to say that means it's unphishable, but I don't think you'll see that written in any docs because security researchers, I guess, are wary of when we call the Titanic unsinkable. So take from that what you will. I'm going to claim it, but I'm not an authority on that. And that credential itself is actually an asymmetric key pair. So you have a private key, which is stored securely on the device, never leaves the device, and that is kind of by definition, it's private. And it sends the public key up to the browser and then onto the server. So how does a public key help you actually verify your identity? You might be more familiar with using public keys for message encryption. For example, if I have two people, Alice and Bob, Alice wants to write a message and send that to Bob, but also wants to make sure that only Bob can read it. So she wants to encrypt it in the middle. The way we do that these days is with public key cryptography. So this recipient, in this case, Bob, will have his public key and his private key. He'll have to generate them if he doesn't have one. And you can use that public key to encrypt the message and the private key to decrypt the message. That is okay, but at the moment, Bob has his public key. So if he wanted to encrypt the message, he'd have to get it from Alice somehow anyway, which means you don't have it encrypted in the middle. So because it's a public key, Bob can give that to Alice. And then Alice can use that to encrypt the message. And then you know the identity of the recipient is whoever's got that private key. That's why you need to keep the private key private, because if you give it to anyone else, they could impersonate you. And that's kind of the opposite of what we want. We don't want to validate the recipient of the message. We want to validate the sender of the message. So to do that, we'll instead use Alice's public and private keys. And she can give her public key to Bob, encrypt the message with her private key, and Bob can decrypt it or validate it with the public key. And in doing that, it means that only Alice could possibly have sent that message because she's the only one who has the private key. Now, in our case, you could replace Alice with the Authenticator and Bob with the website server. So that's essentially what we're doing here. We'll send up a public key, sign some information, and the server can use that public key to validate it. So the Web Authentication API is pretty new. You might be wondering if you can use it. So you go to the de facto docs of the internet, MDN, and you see this graph with a bit of green and a bit of red, and you wonder, is that the whole story? You know, I see IE in there and Opera, and I don't know many people who use those by default. So you go to a slightly different lens in the data, and you can go to caniuse.com. And this shows the relative usage of each browser in terms of the height of the column. Each browser is a different, each different column is a different browser, and the color of the column represents whether it's supported or not. What's important about this view is that there's a lot more green than red. So globally, it's available for basically 2/3. I think it's 68.88% when I checked it last Thursday or something. So that's cool. It looks like a lot of people can use this thing. But then you've got to think about your local demographic as well. And in that regard, Australia is special. So all those people with iPhones, we now have a big red column. And there's actually more red than blue here, more red than green on this slide. Roughly 45% of people in Australia can use it at the moment. Now, because it's new, things have been changing. So we'll have a look at how that's been changing over time. We start our little story in 2015 when Edge first released experimental support for something like the Web Authentication API. It didn't exist at the time, but it's basically the same principle. Then, because they were doing that, and they started working with the W3C and Mozilla and Fido, we started getting some progress and we had an actual specification. In 2016, about August, Edge released a spec-compliant version that was, again, behind a feature flag. And then we had a little bit of a break. Nothing happened in 2017, and we get into 2018, and about March or April, Firefox enabled it for the hardware authenticators, the external ones. So that's cool. We've finally got another browser, and it's on by default. The same month, Chrome did the same thing. And then Dropbox enabled using it as a second factor for logging into their websites. And then Chrome supported the on-platform ones, that's your fingerprint, like Windows Hello or your Touch ID on your Mac. And then Edge released it by default in November. So we've already had a bit happening, but you still can't really use that platform authentication. So come to this year, then in March, Firefox enabled that platform authentication. The W3C moved the spec to a recommendation, which is basically the final stage of a spec. Safari introduced experimental support on Mac OS, not on iOS. Android in April enabled all Android devices 7+ to act as those hardware platform authenticators. So if you did do the demo on an Android, it would have worked. It will today if you do it as well. And Chrome actually started supporting that on Android as well, which I guess was kind of required for those to both happen. So then you get to this point where you look at it today, and if you're using Chrome or Firefox, the situation is pretty good. You can use the external authenticators or the internal authenticators on any device except for iOS. And you go, there's still a few gaps, but if you went back a year, it looked more like this. And you couldn't use those at all. Now, as we were talking about before, a lot more people had phones, smartphones, where you could log in with a fingerprint than the external authenticators. So this is really where we need to focus. And the fact that we've gone from nothing to this in a year is pretty good. One day, iOS will turn on the same thing that Android did, that sunny day in April. And then we'll go from roughly 30% of people being able to use it with the platform authenticator up to, say, 70, because iPhones are pretty good with having a little fragmentation between different versions. So you can look at this and go, cool, it's got reasonable support now, it's growing. There are a few little quirks. Some browsers support different things to others. It's not really important what all these boxes are, but the red is not supported and the yellow is in development. And you can see there are a few little boxes on each thing. Nothing is completely green. So there are a few little quirks along the way. So we've had a little bit of a roller coaster there. I don't know why they're wearing VR goggles. I think if you're on a roller coaster, the VR goggles are just going to confuse you more. But basically, by coming to today's talk, you can say that you liked WebAuthn before it was cool, which has its own little roller coaster. So this is a view of like early adopters and innovators and early majority, that kind of thing, and showing how the actual percentage that something's used changes over time. Now, I would say we're right in this early adopters phase. Like I said, we're at 30%. You could kind of draw a line there, and that would validate that we're roughly at that point. So I like to be an early adopter, but hey, early majority is cool too. And basically, you can still build this thing and offer it to users. It's not going to take anything away from your existing users, but it does give something new to the users that you do want to give it to. So how do I do that? Well, there's a JavaScript API, like everything. It's actually surprisingly simple, this API. There's a public key credential you can look for, which will tell you if it's supported by your browser. You can use this, it's a mouthful, is user verifying platform authenticator available? And that will tell you if the device itself can act as a platform authenticator. So, for example, that'll tell you if you're using, or if the device has Windows Hello or Touch ID, or if you've got a fingerprint. On most new phones, that's going to be the case, and a lot of new devices have that too. So that's cool. Then you've got registration through window.navigator.credentials.create with some options, and getting that credential with credentials.get, again with some options. We don't really have time to talk about what those are. Essentially, that's the information that got sent between the different parts. So if you got something from your server, you would pass that through to the Authenticator, and that's basically the same information. If you want to look, go to WebAuthn.guide, which is associated with WebAuthn.io. I think the whole thing is built by Duo. So how do you make it better for your users? If I'm telling you that you can actually start building this today, what do you need to do to make it better? Well, you've got a few account management flows to consider. You know, anywhere you would have used the password, now you need to think about what you're going to do instead. So you've got things like registration, you've got login, credential management, and account recovery. Account recovery is a big one that we'll discuss, but we'll get into the other ones first. So you can look at your registration page and go, what information do we want to capture? You know, you're probably going to need a username or an email, something like that. You don't need a password necessarily, and you'll need like a register button because you've got to finish the form. But before you can decide exactly what stuff you need, you've got to decide if you want to use the Web Authentication API to do passwordless login or as a second factor. If you're going to do passwordless, you may not require a password, so you can probably get rid of that field. But at the same time, you might want to still allow people to have a password. There is always going to be a trade-off between security and convenience. So if you do have a password, you haven't gone quite as far with the security side, but it's probably a better convenience for the users because no one's really used to logging in with this thing yet. Then you've got to think about if you're going to register the token now or later. Consider things like drop-off rates for filling in the form. If you add more friction, people might not sign up. You've also got your existing users to think about. So how do you get them to start using it? Well, for example, you could put some hints on the login page. Maybe you have a prompt that users see after they've logged in. In this case, your device is capable of logging in without a password, and see if they want to register it. And then you've got things like deciding what kind of messages you want to display, or how forcefully you want to push people into signing up for this new thing. I guess it's all about considering what your users do, and you can have analytics and those kind of things to decide as well. It's also probably going to change your login page if you're going passwordless. You know. If you're going passwordless, you probably don't need the password field. But maybe you do. You know, maybe you give that as an option. Maybe you have a separate form for logging without a password. You can also go usernameless, which is kind of cool. So you might register with a username or not. Doesn't really matter. But some authenticators can actually handle storing keys on the device that you can just look up. So you get a browser prompt. There are more conditions to meet if you want to do this, and the browser support isn't as good. That's one of those quirks. At the moment, today, it's only supported in Edge, but the next versions of Chrome and Firefox will support that as well. And maybe you want to fall back to using a password, even if they are using passwordless login normally. Then you think about things like managing those devices. You might have one authenticator. If you do buy a YubiKey or whatever, you probably want to get two, and then you can keep one on you, so you can use it all the time. Another one is a backup that you keep in a drawer at home or whatever, in case you lose it. So you've got to think about where someone's going to go to manage those, how you'll identify those authenticators on that page. Maybe you've got things like the date you last used it or the date you added it, so that you can decide if it hasn't been used in a while. Maybe you want to delete it. And maybe if they haven't used it in a while, you want to prompt them to remove it. For their own security, if they don't have that thing anymore, that's a way they can log into their account. So you might want to prompt them to get rid of it if they don't have it. Another consideration at this point is if you only have a platform authenticator registered, you can't actually log in on any other device. So that's where the password comes in. It's a quite useful thing to have. So what if I don't have my device? Maybe let them log in with their password, or think about some other way you can let them log in. For example, Slack has like a magic link you could send. You could do something similar. If you're going to do that, then you've got to make sure you've got their email address. And if they have got an email address, you probably want to make sure you've verified their email address. Otherwise, they just enter the wrong one, and I can log into your account. But what have other people done in this case? I don't want to be the first person to build this thing. I'm already not. Yazza beat me to it. But a lot of the big players like Google and Facebook and GitHub, Twitter, Dropbox have all implemented this in some fashion. Microsoft accounts and that kind of thing as well. They've all kind of copped out and gone for it as a second factor. I can understand it because there are a lot more things to consider if you're going to go passwordless, like we were just talking about. But basically, you go into the UIs and it looks something like this. You have two-factor authentication. You have your devices. You can edit, remove them, change, add nicknames to them. So it's all pretty standard stuff. And I guess for two-factor authentication, that works really well for them because they've already got things like falling back to sending an SMS if you don't have your device on you. So a lot of those things they would need to think about would change. How would I do it? I've asked a lot of questions along the way and haven't really given you any answers, so I should probably do that at some point. So let's do a little bit of a demo, maybe. Cool. Oh, come on. This is going to be fun. Cool. All right, I'm going to have to look at the screen now. This will be weird. So, when I can find my mouse, let's assume I'm already a user of this website. We'll call it WebAuthn because, I don't know, that's what the title says. So I might decide that I want to log in with my password because I have an existing account, and then I get onto this page. Probably what I'll do from there is check if they have a registered authenticator. So I've got some code at the bottom here, pseudocode-ish. You can't see where I've declared those variables, for example. But basically, you'll go see if they've already got one registered, or if they've ignored this prompt before, you won't show it to them. Then you can use that feature detection. There is user verifying platform authenticator available to check if it's available. If it's not, then you can't do anything. If it is, show them a prompt. So we'll see what that looks like. I've hooked it up to this little button because I had to. I couldn't show it straight away. I had to show the code. So now you get that prompt, the same prompt I showed you before, pretty much. You have a device name and a register button to remind me later. If I enter a name like Windows, oh yeah, I did it before. I can actually show you what the code would roughly be. So for example, when I click cancel, I'll set something in local storage to remind me later, or something like that. When I want to register, that's the more interesting part. So in that case, I will make a request to the server to get that challenge and the authenticator details, the relying party details, all that kind of stuff. Then I will basically do some transformations on that data because JSON can't send array buffers, but the API actually expects array buffers. I don't know why they made it harder to use, but they did. I guess maybe they're more secure or something, or it's smaller, I guess, I don't know. So I get those options and I pass them through to window.navigator.credentials.create. And once that's been created, I'll get back a response from the Authenticator, essentially, which will maybe be there because it can be cancelled, or it might not. So I have to check for that in my response handling. Then I will send through the credential, like the public key and the credential ID to the server, get back a response from them that says they've stored it and all that jazz. And if that was successful, I close the prompt. It's not that much code, really. Like, this is kind of all I would have in the app in terms of registering that. I'd make that a reusable function somewhere so it could register on a few pages. So I'm going to go ahead and register that. And this is the prompt I get. So I have a PIN number I need to enter. I could get my key, but that's more annoying. Enter a thing, and we're done. Normally, you'd probably want to show things like your own prompt to explain to the user what's going to happen, you know, that they're going to get a prompt from their Authenticator. And then afterwards, you probably want a success message or something. For the sake of this demo, assume that was there. And then you look at things like managing your credentials. So I might go to my account and then click on this little credentials link. And I can see a list of credentials that I already have registered. You'll notice that the Windows one isn't there because it's a demo, so I didn't bother hooking it up. But you'll still see everything that you might need. So I'll look at this and go, oh, YubiKey 5C. I haven't used it in a while, but I still own it, so I'll keep it. And the NFC actually lost, so let's click remove, and that's gone. I want to add a new one. So I'll click that. I'll get my prompt. Quirk of this particular one, I guess, is that it prompts you for the platform one if you have it, unless you tell it not to. So I didn't tell it not to, so I get that. I can actually cancel that and then see what happens. So I can insert my security key into one of my many USB ports that are not taken up by other adapters. I've got a pin on this. That's an optional thing you can set up with your device. I recommend it because then you can use it as those two factors. If I didn't have a pin, I just need to press the button on it. So that's not as secure. And the pin's pretty low friction as well. So I'll go ahead and enter that. And press enter, I guess. And then I touch the button. So big yellow button on it, I press that. Let's say I'll add an example for that too. This is actually the NFC one that I removed. So I'll add that back. And that's basically it. There's not a huge amount to it. You know, let's say I'll log out and I can show you logging in with that device if it wants to work. So I've got my username. I'd need to enter that still. And I can click login. Pretty much the same thing. I'll get a prompt. You can see that I've been testing. So it's showing me all the credentials I have registered for this site and the many usernames and that kind of thing. So here it's got this WebAuthn workshop. That's that display name that I said from the relying party. I can't figure out how to delete these, by the way. So I would have, but I couldn't figure it out. Let's say I want to sign in as VP Lowry, because that's the username I've got there. Click OK. Again, into the pin. Everyone loves a good pin. And we're in. So that is pretty much how I would do it. And if we're going to go just one step further, and we'll talk about what we talked about, because that's what we do in these things. I talked a little bit about the problems with how we do authentication now. You know, we're sending secrets over the internet, which means that those secrets can be taken by somebody else. We talked about how web authentication is better for us because the support's growing and you don't need to have a password, so that's cool too. The state of WebAuthn, where it's supported, where it's not supported, iOS is unlucky. Actually on that, iOS 13 is coming out in like September, probably. That doesn't support it either, unfortunately. Thanks, Apple. But hopefully that'll be in like 13.1 or something, because macOS 13 or Safari 13, or whichever version they do, will support it by default. So I talked earlier about it being behind a feature flag. The next version of Safari, which is probably also September, will have that enabled by default. So, you know, we get better again. It's just iOS now that we need to wait for. Everyone else is fine. What you should build for today? Well, roughly that. I mean, if you want to follow Google instead of me, which I can completely understand, you can build it as a second factor. But otherwise, go with that. And I also gave you some things to think about for tomorrow, like, I guess, how you're going to handle those new users, or maybe you want to think about things like when you can get rid of passwords altogether. Thank you, everybody.